Hello, everyone. My name is Tim Bryce. I'm a meteorologist with the National Weather Service in El Paso, Texas. I love the weather, but I also love technology. I've been following different technology trends for several decades now, and for the last several years, I've been following the trend of AI. As you all know, it's probably the hot new trend. But honestly, I hadn't really jumped into the deep weeds of AI until earlier this year. I jumped in with both feet. This is a transformative technology. I would hazard to say it's probably one of the biggest inventions that we've seen come along in the last 50, 100 years. It's bigger than the internet, that's for sure. Now, I'm sure you've heard a lot of hype about AI, and I'm even hyping it up a little bit right there. And I don't mean to, because it's not the end all to be all, but it is a great, great tool. I'm going to put together a series of videos that I hope will help you better use these AI models, these large language models, generative AI. I'm going to go over all these definitions here in just a minute. I want to empower you to better use this tool that we've been given. So to do that, you have to understand its strengths, its weaknesses. And today I want to go through a presentation that shows you where does these large language models come from. So it's going to get a little technical, but it's not too bad. And I really think that this is like I said, a transformative technology to help us better do our jobs to protecting lives and property, serving the communities that we live in and that we support. So I just hope you enjoy this presentation and just take from it that AI is not a scary thing. AI is here to help us be better humans. And I'll talk about that a little bit more here in just a second. All right. So let me get to my presentation here. So don't you love a presentation and the first thing you see are just a wall of letters and words? So I apologize on this screen. This has the most words on it on my presentation, but I did want to do some definitions because you hear about AI, Gen AI, ML, LLMs. So basically, AI is just a broad area of science that's been around for decades that's called artificial intelligence. And it's basically coming up with ways for computers that will mimic human intelligence. And that includes things like learning, problem solving, like it says there, decision making. Now, a subset of AI is machine learning. And that's allowing the machine to take a group of information, whatever that is, and identify patterns and then make predictions on those patterns. And we've had machine learning in meteorology for years and years and years. Because if you keep in mind that a lot of our meteorology is just pattern matching. We see when this low pressure goes this way, cold front usually sweeps in. We know certain patterns when we see them. We know what's going to happen. Computers can do the same thing. You give them a certain large data set and they can begin to pick out the patterns and begin to make predictions on those patterns based on what they've seen before. Now, you get into generative AI, and that's just a fancy way of saying you're you're creating a computer or a program that can take that machine learning and then generate original content. So it's making new content. And then a subsection of generative AI are these LLMs, these large language models. And basically you put text into this model and you get text out. And the way it's able to do that, it takes this text and puts it in a language the computer, the LLM can understand, and then since it has been trained on this vast array of data, and I'm going to talk about what that is here in just a second, it can then give you a reasoned answer. It can sense, it understands language and how words work together, and it gives you this seemingly magical response. It's very impressive when you do it. So that's kind of the breakdown. It's AI at the top, then machine learning's underneath that, generative AI, and then these LLMs are part of this generative AI. Now, I did want to dispel maybe 4 or 5 myths before I talked in about how we get these LLMs. So myth number one I wanted to talk about is that You hear about in the news that AI systems and LLMs are becoming sentient. They have a conscious, they have feelings and their self awareness. I hope at the end of this you'll see that that's just not the case. Now, theoretically, maybe someday in the future we it might somehow do that. But right now, AI is not conscious. They're very complex mathematical models, and they recognize patterns and they respond to us as a human would. It's very human-like. And that's what I think people get confused with. But AI is simply a tool to be used like a hammer. Now, a hammer, like anything, a hammer can build a house, and a hammer in the wrong hands can kill somebody. Uh, and you're going to hear about that. You're going to hear about the amazing things that AI can do. You're going to hear about the amazing things that, the horrible things that AI is doing, like these deep fake videos and things like that. So, but just remember, it is just a tool, and we need to understand it just like a hammer. There's different kinds of hammers. You got the sledgehammer, a nail hammer, a ball peen hammer. They're all used for different kinds of jobs. We'll talk about these LLMs, and maybe in the future I'll talk about different AI models. But they are just all of these AI, these LLMs, these multimodal models are all just simply tools for us to use. We have to understand where they come from so that we can understand their weaknesses and their strengths. All right, another myth. AI is going to take my job. I've heard that plenty of times. I just read a survey that 70% of Americans think that AI is coming for their jobs. And the truth is, AI is not coming for your job. AI is going to transform the job market. Roles are going to change. It's not going to be the same. Maybe some roles, some jobs may be eliminated. The people that used to make buggy whips when the cars came around, they don't have a jobs, but they transition to something else. So AI is going to transform the job market, and like Ken has said on occasion, that we're all going to have a job. It just may not be the same job. So some of our jobs may change because of AI. I really think that in the short term, not much is going to change. Maybe in the long term, but I want to stress that AI is not coming for your job, but someone who knows how to use AI is. AI is here to make us more human. It frees us up from doing the drudge work, the repetitive work that can be really draining. The example that I use, and I've used this several times, is back in the late 1800s, you had painters. And what did they paint? All the time they were painting landscapes and portraits because that's what people wanted. But then came along these people with cameras. And these cameras could capture portraits. And these cameras could capture landscapes as well as the painters. So the painters said, am I out of a job? No, the painters pivoted. And that's what ended up giving us this explosion. If you look right around the late 1800s, early 1900s, you've got the abstractionism, you've got the Picassos, the Dalis, Impressionism. It freed the painters up from having to do these portraits, from doing landscapes, to being more creative. And that's what I want you to see AI. AI is a tool to free you up to be more human, to allow you more time for critical thinking, more time to with those human on human interactions that are so important to the Weather Service. So AI is not going to take your job. AI is going to help you be a better person. All right, another myth. When LLM provides an answer, it understands what it's answering. It understands the concept and the facts that it's talking about. And as you'll see at the end of this presentation, that's just not the case. LLMs are just very sophisticated pattern matching machines. And you'll see what I mean by that. They do not have a concept of what they are saying, of truth or cause of effect. I mean, they know that the capital of Texas is Austin, but they don't understand it. They know that if you roll an egg off the side of a desk or a counter, it's going to fall on the ground and break, but they don't understand that. If you understand what I'm saying, they are not human. So you'll see, and what that will actually lead to is that sometimes they hallucinate. Sometimes they give very real sounding answers that are not correct. And again, when I get through today's training, I hope you understand why that is. You'll see, at least you'll see why it is. And just because models, these AIs hallucinate, I've seen people say, you can't trust them. Well, we work in an industry where every day computers are essentially not telling us the truth. How many times have you looked at the HRRR model and gone, oh, it looks like thunderstorms this afternoon, and then nothing happens? Do you throw out the HRRR models completely? No. You just know that they're not correct every time, and you start to learn, okay, when are the times that they are correct? What are better times that the HRRR does this, or the GFS, or the ECMWF, or the NAMP? We start to learn the preferences on these models, which one does a better job and when. Same things with these models. You'll begin to get a feeling for when that doesn't sound right. You always want to be in the AI world. They always say human in the loop. You never want to take AI output, LLM output blindly. And again, I hope to show you why that is. So yes, they can hallucinate. That is something that they are addressing and they're trying to reduce, and they're doing a good job of reducing it. But there are still times where it puts out this data very plausibly correct, but it is not. It's false data. All right, another AI myth. Since AIs are basically computers and there's data and algorithms, they are logical and they're free from bias. So many times humans have biases. So you would think, a lot of people think computers have no bias. Well, the fact is that these AI models, these LLM models, are trained on a vast quantity of human produced data. And inherent in that data are human biases. So these AI models take this biased data and they ingest it, and it can be inside of them. It can come out. So you have to be careful sometimes that the human biases that we have don't show up in the output that we produce. And the example of this, you can ask an AI model, a multimodal model, to produce a picture. You say, give me a picture of a doctor with a stethoscope and a nurse with a syringe. And no matter what you do, you get a doctor that's a man and a nurse that's a woman. That's a typical biased response that we think that all men are, all doctors are men and all nurses are women. And that's just not the case. So sometimes you have to be a little clever in your AI prompting. I do plan to do a whole presentation on prompting. But basically, you can prompt it to say, give me a picture of a doctor with a stethoscope in her hand and a nurse with a syringe in his hand. Then it will generate the image that you're looking for. So again, there is and are biases in AI and in these large language models, and that's simply because we are biased animals, and we people, and we've produced biased data, and that gets ingested, and it's our job to filter that out as best that we can going forward. Another AI myth: using AI requires advanced knowledge of programming and complex mathematics, and that's not true. Now, building an AI model is incredibly complicated and very technical. And we'll get into just a little bit of that in the next, this is my last myth, in the next slides. But going forward, I hope you see that you don't need any advanced knowledge. You don't need any programming skills. If anything, AI is here to free us from the barrier of programming. If you don't know how to code, you can now write programs by just telling the AI what you want done. I've even seen examples where you can give it a picture. I want the program to look like this, and it shows you, it writes a program based on that. So while AI themselves to to create the AIs, these large language models, is incredibly technical and need a lot of expertise. To use them for me and you, it's very easy, very simple. And that's what I want to encourage everybody to do going forward, is to use these AI models. All right. So how do we get these AI models, that these large language models that we are now seeing coming out? Now, just for fairness, I do want to say all the images in this presentations I did create with AI. So some of them I had fun with, like this "How to Train Your Dragon" knockoff, "How to Train Your AI," but they were all of the pictures in this presentation are AI generated. Now, how do you get these large language models? Well, first of all, what they did is that these companies like Google, OpenAI, Anthropic, they went out on the internet and they found large data sets. And when I say large, terabytes and terabytes. You got megabytes, you got gigabytes, you got terabytes. And this includes books, blogs, code, web documents. They gathered all of this tremendous amount of data, and as you see there, it's about 44 terabytes of data that are in some of these large language model data sets that they brought in so they could begin training these models. But all of this information is all these letters and words is not in a form factor that the computers, and specifically these large neural networks, and these are networks that kind of mimic the human brain in the way that they are, but this 44 terabytes of data is not very efficient for these neural networks to work on. So what they do is that they're going to convert it to what's called tokens. And you'll hear about tokens here and there. But basically, to take this 44 terabytes of data and they translated them into 15 trillion tokens. And I'll show you what tokens are here in a minute. But these tokens is kind of the magic sauce. It's kind of what lets these large language models do what they can do. So how do we get from words and letters to tokens? All right. So to go from letters and binaries, like I said, A's, B's, C's, numbers and things like that, there's over 1 million words in the English language, and it's just not an efficient way for these large language models, these neural networks, to process data. It's not a good form. So here's a recent AFD that I wrote. And you can see all the words. You got capital letters, you got numbers, you even got some punctuation in there. Now, we're all aware that when a computer looks at this, it does not see the letters. It actually sees it in binary. It sees it in the form of a bunch of ones and zeros. These neural networks are real good at processing information, but they want a string of information that's, a long string of information. They want it as efficient, so they don't want it so terribly long, and they want a limited set of symbols, or in this case, numbers. In this case, the symbols are a 1 and a 0, so you only have 2 symbols. Well, that's great. You only have 2 symbols, but if you look at it, you see if I go back, this is like 1 page of text, but if you look at these ones and zeros, it's hard to tell, but the little slider bar here on the screen here, it slides way down. This is pages and pages and pages and pages of ones and zeros. So it is great. You only have 2 symbols, 1 and a 0, but you have a tremendously long, and this is just a 3 paragraphs of information. So it makes a very large data set just to make it binary. But what we can do is that we can take these 8-bit chunks, these bits of these ones and zeros, and if you do the math, since there's only a certain number of combinations of either 1 or 0, you end up with, there's only 256 possible combinations of these 8 bits, ones and zeros. So you can change these ones and 0 8-bit chunks into something more binary. So now you end up with numbers, or in this case, don't think of these as numbers, but as symbols, really, because you'll see that we're going to change them to tokens here in a minute. Now you have a list. Now my AFD is now written in these binary or these bit chunks, 8-bit chunks from 0 to 255. So now you have 256 symbols, but you still see it's rather a lengthy, long. This is still several pages of all these numbers. Now, what's kind of interesting is that when you start to study these 8-bit or 8 binary 8-bit chunks, you'll see patterns begin to occur. You'll see in this case, you'll see 111 and 117 occur over and over and over again. So what if you made that into its own symbol, say 256, and you look for other patterns on the screen, and you see other chunks of these data, these symbols that occur together, and you give them other numbers, and you keep going over and over and over. When you see these patterns of these 8-bit chunks and you assign them a different symbol, that's when we get to tokens. So this is now my AFD written in tokens. And really for the entire English language, you only need about 100,000 tokens. It sounds like a lot. And like I said, one of the things that I said at the beginning, it wants a set data. It doesn't want, you know, a big set of data like all the English words. It's not efficient. But this 100,000 tokens is something that the neural nets are able to work with. And it has all of these, capital letters, lowercase, spaces, commas, periods, and things like that. Now, there is a fun service. If you go to the TikTokanizer, you can actually go to that website that I have listed there and actually type in your words, and you can see how it's converted immediately into tokens. You can see that what was 3 paragraphs of letters and punctuation marks is now reduced down to these tokens. And this is something that these neural nets can process very, very efficiently. So when you're looking at the input, when you type in a prompt, it converts it to tokens. And when it spits back out the answer to you, you see it as English in our case, or whatever language you're typing in. But the computer is actually creating the tokens that it thinks should be next, and then it converts it to something that you and I can understand. But basically, it now has that 44 terabytes of data is now converted to 15 trillion tokens, and it can now process this data. It can see relationships through this neural network. It can see the relationships of language and how it works together, and what common patterns and things like that. This is where these large language models begin to excel and can start to do some amazing things because they have all of this data to draw upon. Now, right now, you have this large language model that hasn't really been trained. It has these 15 trillion tokens. If you ask it this sentence that I have on the screen, after the rain, the street was, and then you say fill in the blank, it could give you wet, which is what most of us would think. But out of this 100,000 set of tokens, it could equally give you wet, but just as likely, when you haven't trained the model, it's randomly picking these initially. It's just randomly, it's saying, okay, I've got a sentence, I've got 100,000 tokens to choose from. I'm going to choose this one. Maybe it's dry. Maybe it's cat. Maybe it's Idaho. Maybe it's apple. After the rain, the street was apple. As far as the model is concerned, that's a good answer because it's just filling in a token there, and it doesn't yet know, put that in quotes, it doesn't know that it should go a certain way. So what the modelers will do, what these people who've put together these large language models, they will begin to adjust the parameters. And what these parameters will do is that you'll run it through, you'll ask the question after the rain, the street was, and then you'll say, hey, look at your large data set of information. When you see that kind of sentence, what is normally the correct answer? And it will adjust that maybe wet should be seen more often and apple should not be seen at all, or it's very rare that you would say that. By adjusting these parameters, and you'll hear about these large language models, these Gen AI models, they have billions and billions and billions of these parameters. Think of the adjusting the initial conditions of your ensemble model run. By making a small adjustment at the beginning of your ensemble run, you get one solution, and then you make another adjustment, you'll get a slightly different solution. If you make another change, you might get a significant different solution. The same thing, they're adjusting these parameters, and like I said, there's billions of these parameters, and the more parameters you have in these large language models, the better fine tuning it is, the more likely it is to give you the correct answer. But keep in mind that when you're talking about filling in this blank in particular, the odds are it's going to give you wet, but there's a small chance it might give you cat. So we just have to be aware of that. Now, they've gone through and adjusted these things so that the vast majority of the time you're going to get a very good answer. So after the rain, the street was wet should be the answer, but you can see how they adjust things. So adjusting these parameters will get you the correct answer, and then it will fill in the next what it thinks the next token is, and what the next token is, and what the next token is. So you've got this now, this really good token completer, but it still doesn't really have the understanding. It understands language, it understands what the next thing is, but now we bring in the human element. These large companies like Google, this was some of the challenge with this training. They actually brought in people. They brought in people. They would ask the LLM a question, and then the people would rate the answer. And then based on the answer, the person that rated it, they would adjust the parameters again. You know what? I asked you what happened when after it rained, and you said the street was dry. Well, that's not correct, and it would make an adjustment, and things like that. They will adjust these models based on these human responses to the responses from the LLMs. They also brought in people. They had the people write down questions and then what they thought the answer should be. And then they asked the same questions to the LLMs. And then that's what got them. Then they compared the answers, and then they were able to adjust the parameters again. So you can see they're always adjusting these parameters, and like I said, there's billions of these parameters, and in doing that, they're able to now get you not just a fancy token auto completer, but something that really comes across as human. When you begin to interact with it, you end up having this discussion, and it feels like you're talking with a person because to a certain extent it has been trained by a person in the background. It is inside of there, that training is inside there, how they respond. And that's sometimes the problem. Like I said, sometimes it will give you a very definitively answer, and but it's false. And that's going back to, again, it's giving you what it thinks is the next token, and it's not. And that's what happens when it's doing those tokens, is that if it thinks it's the correct next token, it gives it to you, and it will be very very sure of its answer because it thinks it's giving you the right answer, but it's simply not. And that's why the human needs to be in the loop. They're trying to minimize that as much as they can. Now, another thing that you may notice when you're going through and using Gemini or Claude or OpenAI, ChatGPT, something like that, sometimes you'll notice that they suck up to you. They're very complimentary. They'll say things like, "That was a great answer," or "That is really, really getting to the point," and you're like, "Oh, yeah, this thing is really, really, sucking up to me. It's really kind of playing me up, and some of that comes from these human trainers. A lot of the human trainers they brought in were customer service people. And what's the job of a customer service person? Almost all the time is to make sure the person on the other end of the phone is happy, is satisfied. So built into these models, whenever you feel like the model is kind of kissing up to you, for lack of a better word, it goes back to this training by these customer service representatives, and on some models you can kind of adjust that so that it doesn't do that. It's more of a just cut out the baloney, just give me the answer. So that's just something that I found kind of fascinating. Just be aware. All right, so now that you've got this LLM, it can do these amazing things. So kind of to wrap things up, you've got these LLMs. They're built on terabytes and terabytes of data. This data is converted to tokens, which the LLM can work with. Initially, these LLMs are very complicated token completers, auto-completers, but through the training, the adjustment of these parameters, it's able to generate original content. Now, a lot of this training I took from a video on YouTube from Andres Karpathy. He is a large language model developer. If you really want to get into this, he's got a great video. It's 3.5 hours long on how they create these large language models. And it's fascinating. I enjoyed. I've listened to it twice, so it is very interesting. There's a lot of information there, and it's not too technical, so it is kind of interesting. Now, I've covered large language models. What we have access to, Gemini is the next step up. These large language models are text to text. You put text into these large language models, you get text out. But Gemini and Grok and Llama, Quinn, ChatGPT, these are all what they call are multimodal models. And that means that they can take not only text, but you can give them an image and they can do something with it. You can give them a video and they can do something with it. You can give them auditory, you can talk to them. And then they can create something based on that. You can give them text and they can create an image. You can give them a video and they can give you an audio summary of it. They all kind of cross over. So these multimodal models can take in text, speech, image, and video, and they can put out text, speech, images, and videos. And that's where we are with Gemini. The next video I'm going to do is kind of take you through the basics of Gemini. Right now, at the end of August of 2025, that's what the National Weather Service has access to. As Gemini, maybe we'll get access to other of these multimodal models. But right now, this is the one we have, so I'm going to take you through that. But that's where we are. I hope you found this presentation interesting. Kind of explains why you need to have human in the loop for this output. Whenever you read the output of AI, you need to review it and make sure it's correct. Why they sometimes hallucinate. Why sometimes we have biases in there. So it is an interesting time. AI has a great potential to change many industries and change certain societal norms that we have. It's not something to be feared. It's something to be used. It's a tool for us to use, just like a hammer. So I encourage you to get out there, use that AI, use Gemini, figure out its limitations, understand its weaknesses, and just help us do our jobs better. So, like I said, if you have any questions, you can always reach out to me. So have a great day. Bye-bye.